Alrighty, welcome ladies and gentlemen to the video on the number e. You could actually see this number on your graphing calculator. If you look on the left side of it, you'll see e to the x. That's that's a way that you can take the number e and raise it to a power. You can also see it on the right side, right above the division sign. You'll see just plain old e. You put that in, you'll get the value of e. So what is e? Let's take a look. This function keeps popping up in certain applications. You don't have to memorize it necessarily right now, but this is where e comes from. This is the birth of e. This is the mother of e. If you take this function and make x really, really big, as it approaches infinity, this function actually approaches a value, like a horizontal asymptote, and this is the number. Nothing special about that. We've seen horizontal asymptotes before, but this number is so important it keeps getting used over and over and over again. So kind of like what people have done with the number pi, where they rounded it. Well, they didn't round it. They just created some sort of visual representation of it. They used a Greek symbol pi to represent the number 3.1415, so on and so forth, as the ratio of circumference to its diameter. People also decided that instead of writing the same number over and over and over again, we're just going to assign a letter to it and call it e. So it makes life much easier to calculate. So the numeric value of e is approximately 2.71828. Okay, so now where does e pop up? Let's talk about applications. You ready? Interest. So before we get into the equations for interest, I just wanted to lay some ground rules about what these letters will stand for, because you're going to see some equations. A in an equation represents the balance of an account, meaning after a certain amount of time, how much is in there. P stands for the principal. Now that's how much you've initially put in there. This is assuming you take, say, $5,000, put it into a bank account, don't touch it, and then let it grow. That $5,000 is your principal, and your balance is how much is in there at any given point in time. R is the rate at which you're earning interest. It's given as a percent, and you need to convert it to a decimal by dividing that percent by 100. So if you're given something at 3.2%, to use it in the equation, you would take 3.2 and divide it by 100 and get 0.032. That would be the number that you would use in the equation. So you always have to do this step. Take your percent and turn it into a decimal by dividing by 100. Okay. T is time, and specifically in years. This can be tricky because sometimes I can ask you, what's my balance after 6 months? You would then need to put that in terms of years, which I know you guys can do. It'd be 1/2. So your t value there would be 1/2. And then last but not least, n is the number of times that your interest is compounded in a year, annually. So what does that mean to compound? Just really quickly, scenario, I invest $100 into a bank that grows at 5% every year. Okay, so my initial investment, my principal is $100. My interest after a year is $5. 5% of 100 would be 5. Then it's compounded, meaning the principal, 100, is combined with the interest earned, which is $5. I now have $105 in my account. For the next year, my interest is calculated using $105, not 100. So to compound means to take whatever your balance is and the interest you just earned and putting them together so that it can earn interest off of the interest as well as the principal. Okay, that's a good thing. You don't want to keep earning money off of the principal. You want to then combine it so you're earning money off of a higher number. That'd be ideal. Okay, so let's look at, there's 3 different equations because there's 3 different options that you have going into a bank in terms of how you can get your interest. Okay, you can get simple annual interest. This is a really nice, easy thing. This just means that once a year, they take a percent of what you have in the bank account, then they add it to it. So the equation for that is your balance at any given point in time is equal to your principal times 1 plus your rate, all raised to the t power. Okay? So pretty straightforward. The only thing you got to be watch out for is that remember that your r value has to be your percent divided by 100, and then your t value has to be in terms of years. Now, if it's compounded more than once a year, they're going to have to tell you that. It might be compounded twice a year, or 4 times a year, or every single month, which would be compounded 12 times a year. If that's the case, then your equation changes. Okay, your equation becomes 1 plus, you take your rate and you divide it by however many times it's compounded. That's the first change. The second change is that you don't just raise it to the t, you raise it to the n multiplied by t. Okay? So again, as an example, if I get a bank account that's compounded monthly at 4%, my R value would be 0.04. Because it's compounded monthly, monthly means it happens 12 times a year. My n value would be 12 here. I would also have a 12 here, and I multiply that by, well, whatever the time is that I'd like to check it after. Okay. The last option is to compound continuously. If you compound continuously, it gives you a really nice balance. This is the equation for it. Your principal times e raised to the r times t. Okay? So that would be the equation for something that is compounded continuously. This is the type of stuff, whether it's simple annual compound interest or compound interest that happens more than once a year, or it's compounded continuously. This is information that would be given to you in the context of the problem. Okay, so once you have these written down, I'm going to go through a couple of problems with you just so you can see what this looks like done out. Okay, so in this situation, we're taking $9,000, investing it at 3%, and it's compounded annually. That means just once a year, it's combined, and then for the next year, that new balance is what is earning interest. Okay, so that's simple annual interest. Find the balance in the account after 3 years. Okay, so the equation we're going to use is this one. It's not compounded more than once a year, so we don't have to divide our rate into pieces of a year. We just use this guy right here. We'll find the balance. Okay, so I'm looking for balance. Equals my principal amount was $9,000. 1 plus my percent of interest is 3, and remember we have to divide that by 100, so it's going to be 1 plus 0.03 raised to the t power. That's 3 years. I want to check after 3 years, so there it is. You can clean this up just a little bit if you want to. That would be 1.03 raised to the third power. And then we let our calculators do the work from here. We just plug that directly into the calculator, and then it spits out a number at us. And that's the number that we use. It would be $9,834.54. So after 3 years, it gained about $834.54. Okay? That's simple annual interest, so it's compounded once a year, compounded annually. Now we're going to look at a couple of examples where it's compounded more than once a year. In this case, we're investing $12,000. Our interest rate is 4.5, so it grew a little bit, and we're leaving it in there for longer. We're checking it after 5 years, so we're going to get much bigger amounts. All right, it wants to know what is the balance if it's compounded quarterly, monthly, and continuously. All right, so quarterly means that it's happening 4 times in the year. Okay, so we have to actually split up our rate 4 times and then raise that to the 4t. All right, let's do that. A equals P1 plus, my rate is 4.5. Remember, you have to divide by 100, so it's 0.045 over 4 raised to the 4 times 5. Okay? So you can clean this up a little bit if you want to. I didn't put in the principal, so I should probably do that. 12,000, 1 plus 0.045 over 4 raised to the, we can call this 20. And then you can plug that directly into your calculator. It'll spit a number out at you. It'll be a nice number. It's $15,009.01. Okay? All right, now if it's compounded monthly, that means that there's more chances for it to grow. So it's going to be a bigger number. $12,000 initially invested. Our rate is still 0.045, but it's going to be divided up 12 times throughout the year. And let's see, so that's going to be 12 times, again, it's still 5. So again, you can clean this up. You can combine the 12 and the 5 to make 60 if you want, but you can plug this in just into your calculator, and then you're going to end up getting just a slightly bigger amount than if it was compounded quarterly. $15,021.55 is what you end up getting. Okay. Now, compounding continuously is a little bit different than the others. It's not doing it once a month or once a week or something like that. It's continually rolling into itself. The equation for that, if you can recall, is this. Oops. That shouldn't be right next to it. That should be an exponent. So give me 1 second. I'll take care of that. You talk amongst yourselves. I'll give you a topic. Rhode Island, neither a road nor an island. Discuss. Okay, that's in the exponent. There it is. P times e to the RT. So our balance is equal to 12,000 times e raised to the rate is 0.045 times, and the time is 5 years. So you can enter this into your calculator. This you would have to, I would use the e to the x button, the one right above the ln, kind of right next to where the 4 is. So you'd hit 12,000 e, and then it'd give you the little caret, or put it up in the little thing, and you do 0.045 times 5. If you did this correctly, I can give you a little check because I have the answer right here for you. It's $15,027.87. Okay, so there you have it. You have an example, two different examples of compounding more than once a year, an example of compounding continuously, and an example of it being a simple annual compound, so it only does it once a year. That should be it. So hopefully you have this filled in on your note sheet. There's more practice problems for you to do. Use these as models. Please do so. And then, as always, if you have any questions, bring them into class. I'd be more than happy to go over them with you. Alrighty. Thank you, guys. See you in class.